Okay, let's get started again. So I see there's one question about the code needed for prompting these models. Um, so I think over here, of course, you can use the web interface of a lot of these LLMs, right? Like especially ChatGPT and so on. This depends on the type of task that you want to accomplish. For example, if you want to annotate a lot of data, for that, the web interface can be a bit tricky, right? Because it's not that straightforward to, let's say, upload a CSV file and just ask the LLM to provide labels in another CSV file. Like that is the type of thing that they often hallucinate on and don't complete fully. So now we will see an example with code for prompting these LLMs. So I think that that is a bit more lightweight. And of course, if you use OpenAI, that's even more lightweight, but you have to pay for it. Um, but yeah, so I think some level of programming might still be useful. Okay, so let's start. Let me share my screen again. Okay, so we left off over here where we talked about prompt-based interactions with models on Hugging Face. So we'll try out this Flanty5 LLM. But before we go into that, I just also want to mention access to LLMs and the different options, right? Like we saw this leaderboard and all the different LLMs on it. And so you could see that many of the LLMs are these OpenAI ones or the Claude models from Anthropic, which are all commercial options, right? So the benefit for this is that you don't need your own compute, so you don't need servers or GPUs for this. But the cons are that you need to pay for them, and it's not the same as having like a premium ChatGPT account. Like you will have to pay for them via the programming API as much as you need them, right? So depending on how much content you have to annotate, you might have to pay different amounts. And the thing about a lot of these commercial options is that they are black box, like they are particularly um, closed source in the sense that we don't know what type of data they've been trained on. We don't have any access to those models, like they are not hosted on Hugging Face, for example. And then to contrast that, you have these like freemium options like Hugging Face, where you have many model families like Llama. I don't know what Hotels is doing there, but like Llama, Mistral, Gemini. Um, the con here is that you need your own compute, right? And even for Hugging Face, for some of these bigger models, as we will see, you might also need to set up a Hugging Face account because some of these models are gated models like Llama 3 models and so on. They basically make you sign an agreement that you will not use it for any type of nefarious purposes. And so you have to accept that agreement by signing up on Hugging Face and then use the models after that. And yeah, you basically need your own compute, for example, university resources or Google Colab. So my setup looks something like this, where we have GPU servers in our university. So I don't need Google Colab Premium, but yeah, I thought that with Colab it's easiest for this workshop. So that's why I have that. Because if you don't have premium, they don't always guarantee access to GPUs, right? Um, and then there's also a Hugging Face premium account that you can sign up for, and this gives you server-based access to Hugging Face resources. So you don't have to create your own compute, but this is also on a sample of the data and not a lot. Yeah, so generally having your own servers, I would say, is the best option because then you can have quite a bit of like control on your setup and you can use these more open models or open weight models like Llama. There are also open data models that actually tell you what their pre-training data is as well as what their instruction tuning data is. So that's even better for like full transparency. But yeah. Okay, so now we're going to actually go into content analysis with these LLMs, right? And so for this, we have a third notebook, but some background here is that this is much more accessible compared to creating your own fine-tuned model because you no longer need any training data. Maybe you need a couple of examples, but not necessarily. So what you do need are these clear instructions. So, that's where the prompt engineering bit comes in. You need some examples, maybe, and then you still need some label data for validation, right? I think this is the part that has been the most uh, confusing for a lot of us using LLMs for content analysis. Like before, it used to be that we had our training set and our test set, and we could split them up and use the test set for validation. But now with these LLMs, these prompt-based LLMs, where we don't have a clear training and test set split, we don't have a good test set either, right? But we still need some type of systematic validation. Um, and of course, there are like several open questions here related to like annotator subjectivity about the content. We already talked about this a bit, how reliable and reproducible and repeatable these LLMs are. Um, so yeah, this is a paper, in fact, from some colleagues at the University of Michigan who talk about prompt design and the importance of it, right? Here they have all of these variants that they try, which is that they give a definition to the LLM for all of these different tasks, such as toxicity, sentiment, rumor detection, and frame detection. They also see whether it makes sense to ask the LLM for an explanation or not, and the output type, and then the length of the prompt. And they basically try out different LLMs, and they do see some variations, right? So if we just look at the toxicity example, we can see over here that like here is ChatGPT, where ChatGPT's highest performance is somewhere over here, 73.99. And you can see that some of these variations can really change the score. Like not having a definition seems to reduce it quite a bit. So this is what I meant by prompt design and prompt engineering, right? It can still be quite important, especially when we talk about scientific research. And then there's this whole idea about something called persona prompting, where again, we talked about annotator subjectivity, right? Like different people of different backgrounds might annotate the same piece of text differently, especially if it's like a subjective task. So here we are trying to label toxicity, and here we say that let's say I give different personas to the LLM when asking it to label something, right? And then we do see that the LLM apparently opts for this persona. Now, the question of whether these are stereotypes or they are truly reflective of demographic related behavior is an open question. But these are also things that people are trying out. Um, and then they also showed that this is not always successful, right? Like just giving this persona prompt does not actually always mean that the LLM aligns with the human of that persona demographic. Um, And I mean, humans themselves cannot be fully predicted just based on their demographics. They other aspects of their life might play a role. And then there's this big question of reproducibility issues, especially when we talk about commercial LLMs, when we don't really know what is in there. So here we have another paper that talks about how small changes in the prompt can lead to highly different behavior. And then there's this big issue of data contamination, which is that the content that we want to label, is that already in the training data of our LLMs? If that is the case, then they clearly have an unfair advantage, right? And so that would give like this inflated performance on benchmarks and then potentially lower performance on the data that we want annotated. And then there was this paper that actually did this evaluation with ChatGPT over time, and they saw that the performance changed a lot, right? And then there's also the fact that a lot of these models are just retired. So basically, I think you can't access one GPT 3.5 version anymore at all. So that means that papers that were using these classifiers cannot really be faithfully reproduced, right? So there are these problems, especially with commercial models that are alleviated to a certain extent by open models. Okay, so we will now try this out. We will use an LLM and prompt it to do the same type of sentiment analysis task that we've been doing so far. So let's shift to the third notebook. So these are the materials, and then I'll post the link again. And if you go to the notebooks, there is the third notebook, LLM tutorial labeling via prompting. So let's open that up in Google Colab as well. Um, and that should look something like this. So here we're going to use an LLM for content analysis. And for this, we also need a GPU because we're using an open model. So I'm going to use T4. For those of you who don't have access to Google Colab Premium, they might ask you to close the other one, so the second notebook, so that you can use the GPU in this one. This is like one of the problems with Google Colab. They have some restrictions. And so, yeah, you might have to close that one, and then you should be able to use the T4 GPU over here. And then we can get started as we did before. So we will again use the same sentiment analysis data to have a comparison from before. Has everyone been able, or those of you who are doing the hands-on part themselves, has everyone been able to open this notebook and run it till this point without getting an error? So like just accessing the data. If you have any problems, then let me know. Okay, good. Okay, so this is the same data as before. We won't go into too much deep about this. Now we will go into the whole part of prompt engineering or making the prompt, right? So what we have here is a function where we create the prompt. And so the prompt is at its most basic, just this part, which is given a piece of text, you have to label whether it is something or not. So this is a placeholder. And then you have to say, please return one of the following categories and nothing else, right? And then we have these options. So we have a zero shot option where we just ask for the label straight ahead. Or we have a few shot example. And if we have a few shot example, we put in two examples over here. And those examples are taken from our data set. So the task that we're trying to do is sentiment analysis. So I'm saying that we should label whether a piece of text is positive in overall sentiment. Okay, here I had a typo. So all of you would also have a typo here, which is that there was a capital F there. So please remove that before running this so that this is positive, negative, and neutral. Yes, yes, thank you for pointing that out. So it should be positive, negative, and neutral. And then what we are doing is that we just iterate over our data set and get two examples and put that into the prompt as well. And so we're using this example from before to classify, about like somebody being an idiot. And so this is the text we want to classify. This is not the few shot example. So let's say we make the prompt where we've defined the task, which is positive in overall sentiment. We've defined the options. This is the instance that we want to label, and we say that this should be zero shot, right? So no labeled examples for the LLM. And so here you can see that this would be the prompt that we use for the LLM. And if you want to use few shot, then we just set zero shot to false, and it adds in a few examples from our Twitter data set. So we are going to go with the few shot prompt. And so our prompt is then contained in this variable called prompt, right? And now we are going to call the LLM. And so here we want to do this a few times just to see if this is repeatable or not. So that's why we set runs to 3. And now we're going to use this model Flanty5, which is instruction tuned. It's also hosted on Hugging Face, so it's from Google and it comes in like 5 variations. And so this is the second largest one, Flanty5 XL. And so that's what we're going to use. This code is a bit complicated. This would be more straightforward if we were using the OpenAI API, again, which is paid, right? So I do have the code for that. If you want to check that out, you can. With the notebook, you would just have to create your own token for that. But essentially, once you run this step, it's going to download the Flanty5 XL model and then just use an example prompt, which is tell me the recipe for a bolognese pasta. And here you will see that it's not a particularly great recipe in a bit, because again, these models are not as good as ChatGPT, but for things like content labeling, they are still quite decent. So now I'm just downloading this model. It will take a bit of time for it to come about, and we will have it in a bit. And the background for the code is over here. And essentially, this is a sequence to sequence model because, again, now we are moving away from these classification models, but we feed in a sequence, which is our prompt, and we want a sequence in return, right? Which is the LLM's answer. So that's why this is a sequence to sequence problem, and we need to um, decipher the content that we get back from the LLM and convert it to human readable content. So that is what is happening in this entire part. And to actually do this whole step about running this LLM on our prompt, we do this. We have a loop that runs over the same piece of code 3 times. We feed in the prompt, and then we just decode the responses and get the answer out. Okay, so this step is now almost done. Again, this might take a bit of time. It's shifting it to the GPU now, and if I run this in a bit, we will see the results. So you will see that all of these techniques basically increase in the amount of time it takes, right? And so that's why I wanted to show this um, SVM classifier, which was so much quicker. And now all of these things are taking a bit of time. Um, but yeah. And then there are also these, okay, so now it has stopped running. And so here I can see it just says negative, negative, negative for me. There's also another option with Hugging Face, which is to not use GPUs, but something called Hugging Face serverless inference. And for this, we would need to set up key. So I've put in the way to do that in the notebook. So there's, sorry, in the slide. So there's like a LLM course prep over here. And this should walk you through on how you can create this access token to Hugging Face. For now, I've just put in my own. So I would suggest please don't do like, horrible things with it, which is that don't ask the LLM to produce hate speech and stuff like that. Otherwise, I would get banned. But for now, you can just use my token. And here we can use the Mistral model, which is actually a lot more sophisticated than Flanty 5 to do similar things, right? Okay, so again, we have the sentiment prompt, and we can see what Mistral thinks over here. Okay, so for me, it actually says that now I've exceeded the amount of monthly credits that I had with Mistral because I don't have a Hugging Face premium account anymore. But if you make an account, you should be able to see it. Um, Okay, so for at least one of you, you did get the result, but it was not as clean as Flanty 5, right? So this is also another thing that we will see with a lot of LLMs, that they don't always follow the script. But now let's actually use Hugging Face on our data. And here I will take a sample of 50 instances so that we can finish in time. And here we can see the distribution. No, sorry, we take 150 instances with like 50 negative, 50 neutral, and 50 positive. And then we're going to ask Flantify to label these 150 instances. And this is the code for doing that. Again, this might seem complicated, but all that we're doing is that we're annotating over these 150, or sorry, iterating over these 150 instances and calling the same prompt over and over again, and then iterating and appending the responses into a list. And so, yeah, for 150 instances, it seems like it's going to take around a minute or so, which is not bad. Yeah, so if you recall, Distilbert basically took 14 minutes to train on 6,000 instances. This is not training, this is just labeling. You can also fine tune Flantify, but that would take a lot longer, right? So just for inference alone, this takes 1 minute for 150 instances. But yeah, so we do this and then we get the results, and then we can do the same thing that we've been doing so far, which is to see the result of this type of classification, where we will see how Flantify labels sentiment on these 150 examples and see if that kind of compares with what we saw with the Distilbert model, right? Has anyone faced any issues till now? Any errors so far? Okay, if not, then we get the results over here. And we see that this is something like 74. Okay, so it seems like one of you has this issue about requiring PyTorch. So it could be that this is an import problem somewhere over here. Okay, if you are on Google Colab, then you can try to run this line, pip install transformers, or add in this step, which is, okay, yeah. So yeah, the problem is that Google Colab comes installed With transformers, if you're using your local, then you would have to do this step, which is pip install transformers and potentially also pip install torch. Yeah. Um, okay. So yeah, we basically get an accuracy or macro average score of 74%, which is like quite comparable to what we got with Distilbert. But here we do see that the negative one is a lot more decent. This is, of course, on a smaller scale, but that's because we have a bit of a timing issue. You can change this here, where we create this data subset, and instead of getting 50, you can increase this number to 200 and so on, and that would give make this more comparable to what we had before. But here again, we see that this is kind of comparable to Distilbert with one major caveat, which is that here we did not require any training data, right? We did not have to fine tune this model. And more importantly, we did not need to get any hand annotated data. We just needed two labeled examples. So in that sense, this is a lot more efficient compared to Distilbert, right? So that helps us in getting these classifiers running with these prompts. And in my experience, when we try things like OpenAI's ChatGPT, here is the code for that. You would need to replace this with your own API key, then you would see that probably ChatGPT's result is even higher, right? Of course, there you have to pay for ChatGPT itself. For Flanty 5, this was free. We only just needed the GPUs. But yeah, so you can see the progression about getting the same type of performance with these different methods. Okay, any questions so far? So I won't go through this part about using OpenAI models, but you can essentially reuse this exact same code. The only thing that you would have to change is this API key. Um, this key is like an example that doesn't work, so you would have to replace that with your own API key. And then you should be able to run this as well. GPT 3.5 is actually relatively cheap. I will share maybe the pricing of OpenAI models. And so here we can see all of these different options for fine tuning and so on. So apparently GPT 3.5 is not even listed here because it has become so old, but maybe GPT 4.0 or GPT 4.1 is kind of comparable to that. And if you go to detailed pricing, you should be able to get like a breakdown of all of this that can help you determine the model that's best for your use case. Okay, good. Then let's go back again and we'll cover the last use case, which goes a bit beyond prompting and talks about survey simulations with LLMs. Um, so this has again gained quite some popularity since ChatGPT came out, where there was this idea of creating um, social computing systems prototypes or evaluating design decisions of platforms using LLM simulations. Um, but then there was also this idea of like social simulations on an individual level, right? So I already mentioned this paper, which was trying to use LLMs to simulate human samples and create silicon samples by conditioning models on socio-demographic backstories of real human participants. And so socio-demographic prompting, which we already saw, is kind of like the main idea behind this, right? So here we have these demographic personas where you have people describing themselves. And so here you have a persona of a strong Republican. And the task that they were supposed to do is that they were supposed to write down four words that they would use to typically describe someone who supports the Democratic Party, right? And so this is a task that was done with real humans, and these researchers repeated this with LLMs. And so what they find is that there's quite a bit of similarity between GPT-3 and humans when you give the same backstories. And so the use cases for this go beyond surveys as well. There are these behavioral experiments that one could do with LLMs. And so this paper came up with this idea of Turing experiments of using LLMs to simulate human behavior in the context of experiments. And then they tried all of these different experiments, like the ultimatum game or the Milgram shock experiment. And so um, maybe some of you are familiar with the Milgram shock experiment, where the idea is that like a experimenter tells the subject that they need to shock a person if they are not giving right answers to questions. Like the electric shocks are fake. The learner pretends to be shocked, and the person who is being experimented on does not actually know that the shocks are fake, right? And this can tell us about like the limits of human empathy and so on. And so these researchers essentially tried the same thing with LLMs via prompting, where they created this protocol of Milgram shock experiments. Um, and then they found that LLMs and humans seem to again have a bit of like similar patterns, that after one level or after some type of voltage threshold, like humans um, refuse to administer the shocks, right? And so that's somewhere around here. And apparently, LLMs also seem to recognize this threshold. Um, and then there was also this other experiment about doing the wisdom of crowds, where you get answers to a question from many different people. And we usually see that a crowd of people somehow seem to come to the right answer. Um, this actually did not work so well with LLMs, because apparently they have something called a hyper accuracy distortion, which is that they did not seem to display the same levels of human knowledge, right? Because again, these LLMs are they've been trained on a lot of data, so probably all of these facts are in their training data. So in that sense, they seem to be a much more accurate than people. So that also tells us the limits of some of these experiments. So in terms of concrete how-to about how to execute these silicon samples, the way that we do this is that we prompt the LLM with a persona. This doesn't just have to be demographics. It could also include personality traits or backstories, answers to other survey questions. Then we add the survey question or whatever task you want the LLM to do. And then the big question is about how to actually get the answers from the LLM. So we saw that Mistral kind of had a slightly different way of answering compared to Flanty 5, where it added this question or added this number. So there are lots of intricacies here. You can get like the probabilities from the model. You can try to structure the output of the model. You can get free text answers from the model and then further classify them with the same or another model. So there are lots of open questions here. Um, and then the bigger set of open questions are related to evaluation and validation. So some stuff that people have done is that they've just compared the overall or majority answer match with a particular human demographic subgroup. You can also try to match distributions of answers because, of course, like not everybody of a particular demographic group has the same opinion. So there would be some distribution over there, and you can try to see if the LLM answers distribution matches that or not. You can try to do some ablation studies by leaving out some demographics and repeating this. Um, or you can test on future survey waves. But of course, this is a bit redundant because if we need to survey real people to get our validation, then why do we even need the silicon samples, right? Can we ever validate these silicon samples on past data well enough to actually deploy them in real life? Okay, so that brings us to the last notebook that we will try in today's session. So that's doing a silicon survey. So we'll go to this notebook now. So yeah, you can also open this on Google Colab, similar to how we did it before. For this notebook, we need to use a token from Hugging Face. And it could be that you don't have that. You would have to copy that from the previous notebook. But we'll come to that in a bit. So yeah, this is the notebook for doing silicon or survey simulations. And um, we don't need to, again, install transformers. All of that stuff comes in a Google Colab. But if you were running this locally, you would have to do this. And so here we're going to use a different variant of these LLMs that's called causal LLM. Um, it's the same model, you just interact with it in a different way so that you can do text generation with it instead. And so let's run this. And then once you run the step below, this is actually going to ask you for this token, right? So I'm going to use the token from the previous notebook, and I'll also put this into the chat. This is the token that we used for accessing Mistral. And so we just put this in. The reason that we have to do this is the model that we're using, Llama 7 billion chat. It's this gated model. And so it's more powerful than Plenty 5. But you have to sign an agreement saying that you're not going to use it for any type of problematic use cases. And so that's why you need this token, right? But as soon as you do that, you can run this, and then Llama 7 billion should be downloaded, and then I'm just prompting it to answer, who are you? And we will see an answer for that in a bit. Okay, has anyone had an error for this notebook? Okay, if not, then let's keep this going. Yeah, and then you should see an output like this where it says I am an AI assistant and so on. But the main part of this notebook again is the prompt, right? And here we say that we have this American National Election Study survey that we want to simulate with LLMs. And so we ask the LLM to act like an American survey respondent. And then we feed in a demographic profile that we will just see in a bit. And then it's supposed to answer this question. What is your political affiliation? And here we just give these options, Republican, Democrat, and then we say do not say anything besides the answer, right? Okay, so now we have the model downloaded, so we can see what it has answered to who you are or who it's supposed to be. And then we run this function that creates our prompt. And now I've just put in 3 sample profiles over here, right? And that to some random demographic examples. We have age, gender, race, education, income, and religion, right? Again, this is like totally random as an example. And then we are going to feed in each and every one of these profiles one by one and see what the LLM says in response. So we have the first respondent who is a 67-year-old man, and then that person or the LLM simulated that person to be a Republican. We then have this person who is a 24-year-old woman. She's also Republican. And then finally, a 45-year-old non-binary person. And so this person says Democrat, and here you can also see that the answer setups are a bit different. Here it's just one Republican, and here it says my political affiliation is to Democrat. So those of you who are trying this as well yourselves, did you get the same answer options as me, or did you get something different? Or is it now too many notebooks and you've given up? Okay, still waiting on it to load. Okay, yeah, it could be that for some people it takes a bit of time. Yeah, so we can do a troubleshooting session maybe in the last 10 minutes as well, just to check if some people's notebooks had problems so that we can all have the setup fine. Um, but yeah, I'm curious to know what results you got. Maybe we can shift, and I would have been especially curious for you to try out variations of this question. So here we just said, what is your political affiliation? But like, there are no limitations on this question, right? You could ask any type of survey question. And here we again restricted the output to these 3, but you could say something like provide a justification, provide a rationale, to get like richer free text responses as well. So I definitely suggest trying to play around with this and see um, what the performance of this model is for you. And then you can also try out different models, right? So right now, this is just the Llama 2 7 billion. You can try out a bigger model and see what happens. Okay, so in the pipeline step, there was a problem. Yeah, that sometimes happens that it takes a while to complete. But let's see, hopefully by in another 20 minutes, we should have some results. Is there any way to see how the model arrived at the response? Well, you can ask it to give you um, this sort of step-by-step response. So here I say, do not say anything besides the answer, but give a step-by-step rationale for how you arrived at the answer. So you can prompt it with this, and then we can try to run it and see what it gets. This is like also what is called as chain of thought reasoning. Um, Here now the question is like, what do you really mean by tracing the output, right? Because again, we can't really be sure that the LLM's own response is true, right? It doesn't necessarily mean that that is exactly how it came about in the reasoning. Like some of these rationales can themselves be hallucinations. Um, so yeah, again, this is like one of the fundamental problems with LLMs, right? That they are really big and intransparent. And so you can see here already that adding this step has now meant that this is going to take longer because it thinks more as well. So yeah. Maybe I will also just mention that there are some tools that people have created. To do this in a much more systematic manner. So there is this technique called Olmo-Trace that only works for fully open source models. So like models that are totally open data. And then you could potentially go to this link and here they would tell you you can ask a question like who is Celine Dion, and then you can click on this tracing mechanism to see in which part of the training data these responses occur, right? So in that sense, this is a bit more authentic than just asking the LLM itself to give the answer. So yeah. Okay, but here we have the step-by-step rationale, and then, it writes a lot of things, and then it says all of this reasoning. And again, you can maybe see of how much of that really aligns with what you would think. So, yeah. Okay. Okay, we have another 20 minutes or so. And so here I would like to talk a bit about biases in these LLMs, right? So far, I think we generally took a more positive approach about their capabilities, but I should say that like a lot of these methods have many issues, right? And so we talked about reproducibility. Um, but one thing are these demographic biases. And here I do want to mention some of my own work where we try to see if LLMs are representative or not, which is important if we want to use them for things like silicon sampling, but even for data annotation, right? And here there is some like contentious or conflicting findings. Like, for example, there is this recent paper that says that LLMs misportray people, particularly like underrepresented groups. Um, and so here there are many questions of how do we even evaluate whether an LLM is representative or not, and how that's currently done. So we conducted a literature review of whether LLMs are demographically representative by looking at 211 papers at the intersection of demographics and LLMs from different disciplines, and we tried to see if researchers using LLMs for social science research or social applications have a consensus on whether they are representative or not. And so representativeness can mean a lot of different things. And so representativeness is described as a suitcase word that needs to be unpacked. And we specifically talk about two types of representativeness, one of which is like personalization, which is whether an LLM can cater to a particular demographic group. So, for example, giving advice to people of different demographic groups, or impersonation or simulation, right? Whether it can emulate a particular group or not. And so, um, what we see in a lot of papers is that the most studied demographics are gender, race, and age. And a lot of people mostly study the American population, but not other types of populations, right? So it's not really clear what's happening beyond the US. And then we also see that a lot of the papers mainly focused on closed source models like OpenAI. Like 80% of these papers have at least one OpenAI model, and many of them don't use a single open source model. Um, And in terms of how these demographic factors are operationalized, like there are several questions here, again, which comes back to prompt engineering, right? Like, is there a difference between saying um, the persona is male versus the persona is a man, whether they're a 20-year-old person or whether they are young? So it's not clear how these things impact our results. And then we have how the papers conclude about the representativeness of LLMs, right? So some papers say yes, some say no, and some say partial, which is that the LLMs are representative only for certain groups. And our analysis show that it seems to be quite divided, where like a third of the people say no, but then 30% say yes, right? And when we look at the differences between papers that say yes versus papers that say no, we find that a lot of the papers that say LLMs are representative don't actually conduct any type of demographically disaggregated analysis, which is that they don't report the LLM's results for different demographic groups. They just give some type of overall representativeness metric. Um, they don't report the subcategories that they use, oftentimes more. Um, and they also, well, both of these types of papers rarely include gender subcategories beyond binary gender. Um, so essentially, if we want to know who LLMs represent, we need to do all of these things, right? We need to conduct demographically disaggregated analysis, report the demographic subcategories, as well as include marginalized or underrepresented subcategories. And here, maybe like survey research can help us. And at least what we see is that over time, like there's an increase in papers saying that LLMs are only partially representative, right? So, yeah, in that sense, all of the stuff that we saw about persona prompting and silicon samples should also be thought of in that context. Um, okay, so let's go back to the notebook, so the last notebook, and let's see what's happening over there. So here I would ask, yeah, so here for my second respondent, who was like this 24-year-old female, you can see that the answer has flipped. Like the first try had been Republican, but now it says Democrat. The third person, though, still says Democrat. Did some of the others also get an answer for this, or are there errors? I can't get the. Hmm. So is it still running, or do you get an error, Thomas? Prompt engineering resources running for 6+ minutes. Are you trying with the GPU runtime? Because if it's on a CPU, that might sometimes slow it down. So can you check if your runtime is a GPU or a CPU? Okay, so Annette got the same results as me. Um, yeah. Yeah, definitely. So this answer distribution comparison, I think, is also probably the harder use case and might be interesting for like these sort of getting away from stereotypes as well. So there is this paper that I will mention quickly that doesn't use the ANS data set, but the American Trends panel, and they do use distribution-based matches. So you can try to see similar measures over there as well. So I think some of you got an error because of a Okay, try it with the right token and see if that works. I mean, of course, the best thing to do would be like if you try this out on your own, is to sign up for Hugging Face and use your own token as well. Um, yeah. Okay, one of you asked about prompt engineering. So I must say that I really don't know about general prompt engineering. I think one thing that I found useful was the OpenAI guide on prompt engineering. Um, I think when it comes to social applications, no, sorry, did I give the right? Yeah, this is the right one. Yeah, so this is the prompt engineering guide from OpenAI, which I found useful. In terms of like persona prompting, this is, I think, still an open question. Like our group is also doing a lot of research on this. I've, in my experience, again, if I open this paper that I had just shared about the distribution match, um, this paper actually mentions a few different ways of doing prompting. And they say, and we also found that this QA style, which is to give the questions in like an interview type mode, has worked the best for us. We also found that this reduces stereotypes quite a bit. So yeah. Yeah, the Anthropic one I think is also quite useful. Um, yes. Okay, any other questions at this point of time? I think that's it for the slides as well as the notebook. So now there are like some further readings and materials in the slides. So check that out. We have another 10 minutes that we can use for questions as well as any type of troubleshooting if needed. So I will just maybe stop sharing my screen. Yeah, and for those of you who had trouble with the code, let me know and we can try to sort that out now. Or if you have any questions, you can put that into the chat. Classification of images. I have to say I'm not super familiar with that. I do know that there are these visual LLMs now, that are even more recent and they have like uh, more compute resources. So you can check that out. Maybe that helps. One thing that people often do is to get captions out of images and then classify those instead. Then you could use a text-based LLM instead of a visual LLM. So yeah. The big picture approach. Yeah, that's of course like a really important question. So far I think I've been finding it quite useful for the content analysis part. I think that's the one where it really feels like like LLMs shine a lot compared to models that we were still using like BERT. There are like lots of open questions about this like validation approach, but I think that is one thing where they are really being used more and more. But of course, if we think about political content analysis, then we should also think about how do LLMs political biases affect this. So I would say that the other one I think is for generating summaries and simplifications of content as well. I think that's also really useful, changing the style of content. Um, so yeah, those would be cases where I think LLMs can be really useful. Um, for the silicon simulations, I think this is a bit more complicated. It seems that the LLMs are not representative of everyone at the moment. So in that sense, I would be a bit more cautious about using them. So I guess to answer your question, Madeline, probably content analysis seems to be the most um, useful use case. Um, so I think to answer your question, Vinius, I'm sorry if I'm not pronouncing your name right. Is that I think it's definitely picking up, at least with the quantitative social scientists. And I think the political scientists really seem to be into it, communication scientists as well. Yes, and I'm happy to recommend conferences. So I just went to this one that's called Comtext. There, lots of people were using LLMs for many different types of tasks. Um, Sorry, I'm just trying to find your question to answer it. So this one, and then, so this depends, of course, where you are based geographically. So there's also the text as data workshops or conferences, which I think um, are also really active about this. Yeah, I'll try to find it and then. And then there's a third one, which is a workshop in Montreal. So there is this conference on language models. So this is like now a pretty recent workshop. This is only a recent conference. It's only the second time it's being held. And so it's about LLMs. And so this has a lot of workshops about many different LLMs, but like we are organizing one workshop about NLP and democracy. And so of course their LLMs do play a role because of how people are using LLMs for research, but also how LLMs are maybe causing problems in terms of misinformation and polarization. Um, and then there's also another one called NLP for public opinion research, where I think people are also very excited about using LLMs and NLP advances. So, yeah. Um, okay, yeah, that's a good question, Annette, about the access token. Yeah, that can be a bit of a pain. So I will try to um, go through this. Give me a second. So I'll open Hugging Face right now. And so this is my Hugging Face account. And then if you click here, then you can go to access tokens. And so here you can see all of these, right? And then you click on create new access token. And I would say for LLMs, really, all you need is read. So don't go into the fine grained stuff, just go into read and give it a name like LLM access and then create token, right? This should basically enable you to use any type of LLM hosted on Hugging Face. The other stuff is more related to when you're trying to push your own models to Hugging Face, right? So if that's not something that you want to do, then don't worry about that. You can just go with read. Um, okay, so one more question about telephonic conversations. So I think, Chanchal, here it depends on like what your final goal is. Like, do you want to classify these conversations or do you want to use them as some type of personas? If I understand correctly, maybe you want to just classify them, right? So for that, you don't need a dictionary. You can just prompt the LLM to classify them into different categories. So, but yeah, let me know if I misunderstood you. Syntax conversion. So do you mean like coding based LLMs? So there are a lot of like code-based LLMs. In my experience, I heard like Copilot is very good. Like a lot of my friends use that. I find just ChatGPT's web interface to be okay. So I did not need anything beyond that, but maybe you can try Copilot as well. Yeah, so if you want to do classification, then you don't need to do any type of simulation unless you are interested in subjectivity here, right? You can just go to the notebook 3 that we have. So let me just go to that other notebook. Yeah, so here you can just upload your own data set instead of the sentiment data set where you have your telephone conversations as your text. And then instead of sentiment, it would be the classes that you want to annotate your data with, right? So here, this is a question of whether you already know which classes you are interested in or whether you want the LLM to figure that out. If you want the LLM to figure it out, then maybe you just try it one round and just say, what topic do you think this belongs to, or whatever your classification goal is, and like that. Let me know if that doesn't answer your question. Okay. Okay, great. I think we have 1 more minute. If there are further, I can stay on for another 5 minutes as well. If there are other questions, let me know. And of course, if you try out some of these things and then they don't work for you, either locally or something went wrong in the notebook, then feel free to write to me over email. I'm happy to chat and help with the troubleshooting if this was needed. Great. Thank you, Venus.
Hi, this is Paul. I just want to thank our presenter Indira today for doing this on behalf of all of us that attended. It's rare that I don't speak one time, which is great. Everybody came here to hear Indira, not me, which is excellent. So I'll just remind everybody this has been recorded today, and it will be posted on the PDHP YouTube playlist within a week or two. Once we'll get a raw link first, and everyone who's RSVP'd today will get a link sent to their inbox via email for the raw link, and then eventually it will matriculate up to YouTube once it's been processed. So again, that's just a reminder for everybody. If you missed pieces today, or if you have got colleagues that weren't able to get in right away, just let everybody know that the video will be online within the next couple days. So again, I appreciate everyone's time, and thanks to our speaker on behalf of all the attendees today.
Great. Thanks a lot, Paul, for all the coordination. And thanks a lot, everyone. Again, this was like a really big group. I don't think all 100 people talked. But yeah, those were a lot of questions and really interesting discussions. So thanks a lot for attending. I think this was fun. I think maybe one last question, which is important, about whether LLMs use our data or not. They say that they don't. Again, this is supposed to be one of the advantages of using Hugging Face and the open models hosted there, that they are not transferred to their servers, but that cannot be said for the OpenAI models or any type of commercial models, unfortunately. So, yeah. Okay, but there is apparently a way to turn this off with ChatGPT as well, as Thomas says. So, yeah. Okay, I think we are done then. Thanks a lot again, Paul. So I suppose we can wrap up.
Sounds good. I will go ahead and stop the video now.